We're on lesson 4 of chapter 8, which is going to focus on angles inside polygons. So first we're going to find an angle measure in a triangle. Then we're going to find an angle measure in a quadrilateral. Then we're going to draw triangles to find the sum of interior angles in general. So first, finding the angles in a triangle. Something to know is that the sum, or if you add up all the measures of the angles in a triangle, you're going to get 180 degrees. It doesn't matter what shape the triangle is, it's always going to be the case. And since we know that, we can find these unknown measures by solving an equation. For example, we have 45 and 90, so 45 plus 90 plus whatever x is going to equal 180. Well, 45 plus 90 is 135, so 135 plus x equals 180. Subtract 135. X then equals 55 degrees. So knowing that a triangle is 180 degrees, we can solve for x. Quadrilaterals have twice the measure of interior angles as triangles. And here's the reason behind that. All four-sided figures can be divided into two triangles by making a diagonal. So if you notice here, if I go from corner to corner, I can create two different triangles. And remember, each triangle is 180 degrees. Well, triangle 1, which is 180, plus triangle 2, which is 180, that'd be a total of 360 degrees for all the angles. So knowing that, I should be able to solve this unknown measure of x, because I know that 115, 65, 115, and x equals 360. So we'd have 115 plus 65 plus 115 plus x equals 360. These numbers, when added together, give you 295. 295 plus x equals 360. Subtract the 295. And then x is going to equal 65 degrees. So I know that this is 65. So what we just did here by dividing it into two different triangles proves true for any different polygon. So for any polygon interior angles, you can add the sum of any polygon's interior angles by dividing the polygon into triangle. So for example, if we start at this angle right here, we can connect all the lines to where there isn't a line already. So since there's already a line from this angle to this angle, we will leave that alone. We connect these different lines here. We connect these opposite lines. Then we connect these ones, and there's already a line here. Well, how many triangles does that make? 1, 2, 3, and 4. Well, each triangle is 180 degrees, so 180 degrees times 4, that would equal 720 degrees. So even though this figure had many sides, we split it up into triangles and we're able to solve that. So let's try this again in each triangle. We have a 25-degree angle, a 37-degree angle, and x. All of these added up should equal 180. So 25 plus 37 plus x equals 180. 25 plus 37 is 62, so 62 plus x equals 180. Subtract the 62 to get the x by itself. That would give me 118. So x equals 118 degrees. So now let's find this quadrilateral unknown measure. If you remember before, we could split this into two different triangles to show that this is 360 degrees. Knowing that, we could do 98 plus 137 plus 52 plus x equals 360. 52 plus 98 is 150, plus 137 is 287. So 287 plus x equals 360. We can subtract that 287 from both sides. 360 minus 287, that would be 73. X is going to equal 73. Here it asks us to divide the polygon into triangles to find the sum of its angle measures. So we can find out what its complete angle measures are by dividing it all into triangles here. So like before, we can start at this angle right here, or really any angle, and then we can connect any lines that we don't see so far. So we already have a line here, so then we could draw a line there, draw a line there, have a line from here to that angle, and then this one already has a line. So how many triangles do I have? I have 1, 2, 3, 4, 5. 5 triangles. They each have 180, so 5 times 180. That's going to give me a total of 900 degrees.